4.6, complex zeros. In 4.5, we were solving the polynomial functions, and we were only solving that in the real number system, but we did see some imaginary solutions show up. And we also talked about how our imaginary or our complex zeros come in pairs, conjugate pairs, plus or minus. So we're going to look further into these conjugate pairs and develop polynomials from those pairs. And we're going to use the fundamental theorem of algebra to help us with that, and the understanding that if I have a polynomial of degree 3, there will be 3 zeros. If I have a polynomial of degree 4, I will have 4 zeros. Degree 5 will have 5 zeros. So we will be using all those zeros today, and we will be writing polynomials. We're going to find some solutions. We will be finding both real and imaginary solutions today. As we're going through this, make sure you write down any questions that you do have so you can ask me in class tomorrow as we are discussing this further and working on our classwork. So we have 3 examples to look at. Our first example is just understanding the conjugate complex zeros. So if I remember how I get a imaginary number, a complex number, I get that by having to square root a negative. So if I have x squared equals negative 16, when I square root that, get rid of that. When I square root this, I need to understand that first, because I am square rooting, I will have plus or minus. That square gets rid of the negative, so I will have 2 possible solutions here. The square root of 16 is 4, and because I am square rooting a negative, I need to understand that this is the square root of negative 1 times the square root of 16. So I need to pull that negative away, and the square root of negative 1 is I, and the square root of 16 is 4. So I get plus or minus 4i. So when I'm looking at example 1 and it's just finding the remaining zeros, I know I have a degree of 3, which means there will be 3 zeros. Here's 1 0. So it's telling me my zeros. There's 1, 3. Here's my another 0, 4 minus I. Well, right now that's only 2 zeros. So I am missing 1 0. And I see that I have an I, which means I will have a conjugate pair. The conjugate pair is going to be 4 minus I. Plus I. Whoa, man. So my conjugate pair, since I'm given the 4 minus I, it's 4 plus I. So there's 1, 2, 3. My remaining 0 was 4 plus I. Now I'm going to use the same thing over here in B. So I have a degree of 4, which means there are going to be 4 zeros. 2 minus I has a conjugate pair of 2 plus I. And then I see a negative I, which has a conjugate pair of I. So there are my 4 zeros. 2 minus I, 2 plus I. Negative I, positive I. So I have all 4 of them found. So now I'm going to use the idea of the conjugate pairs in example 2, where I'm going to write the polynomial. So I'm going to write this first in factored form, and then I'm going to write this in standard form. So D4, which means my degree is 4, so there will be 4 zeros. So I will need 4 factors. So here it's giving me sum of the zeros. 3 plus 2i. Well, I need to remember its conjugate is 3 minus 2i. Then this tells me I have a 4 with a multiplicity of 2. That means there are 2 x equals 4. So one of my zeros is 3 plus 2i. Another 0 is 3 minus 2i. And then I have a 0 of 4 twice. So there are my 4 zeros. So now I'm going to write this in factored form. So factored form is, we need to understand how, since these are zeros, this is what made the factor 0. So what did this have to be first? This had to be x minus 4 in order for 4 to make it a 0. So this one will also be x minus 4. Now, when I am looking at my imaginary, when I'm writing my factors, it might help you. Like, I could even look at this, since I have these written out as equations. I want these to equal 0. So I'd have to move the 4 back, which makes it x minus 4 equals 0. X minus 4 equals 0. So when I am writing my complex zeros, I would start with x equals 3 plus 2i, and I want to move both of these over here. So this would be x minus 3 minus 2i equals 0. Now when I look at this second one, so here was this one. Let me just use a highlighter. So this one is right here. Now I'm going to move this one. Go away here. So this would be x equals 3 minus 2i. Move both of these over by subtracting and adding. So you'll have x minus 3 plus 2i equals 0. So I have, my mouse keeps moving. Okay, so I have all of my factors. Here's 1, here's 2, here's 3, here's 4. So let's go ahead and write this in factored form. X minus 4, x minus 4, x minus 3 minus 2i, x minus 3 plus 2i. Now, equals 0. So now I'm in factored form. I can rewrite this in standard form. So this is factored. Now to rewrite this in standard form, I am going to make this look like the polynomials that we have been solving. No parentheses, and it will be in order from the largest exponent, so its degree, down. So if my degree is 6, it will go 6, 5, 4, 3, 2, 1. So we're going to have to make sure we do put this in order by the time we are finished. When I am multiplying, I'm going to multiply the x minus 4's together, and then I'm going to multiply my two complex zeros together. The reason for this is I want to keep those i's together because something magical happens. It's not really magic. It just, the negatives and the positives kind of make things cancel as we're multiplying. And then I will also have I squared. And then that, hopefully we will remember from Math 2 and Math 3 what I squared equals. So we'll get to that in a minute. Now when I multiply x minus 4 and x minus 4, this gives me x squared minus 4x plus 16, which is x squared minus 8x plus 16. So there's that one. Let me switch colors now. Let me put this down. Okay, now I'm going to multiply this second pair of parentheses. I'm going to take this first x. I'm going to look at these as three different things that I need to distribute. I need to distribute x, I need to distribute -3, and then I need to distribute -2i. So I'm going to have x times the second parentheses, -3 times the second parentheses, -2i times the second parentheses. So I distribute. This helps keep your work more organized. If you guys can use mental math and keep track of what you're multiplying, that's fine. You don't need to write this out. So I get x squared minus 3x plus 2xi minus 3x plus 9 minus 6i minus 2xi plus 6i minus 4i squared. So one of the things that I notice when I am looking at this is I see a 2xi and a negative 2xi. I see a negative 6i and a 6i. That's a good thing. Because of the fact that these are conjugate pairs, things are going to cancel. And if the i's didn't cancel, then I know I have a mistake here. Now, I have another I left. Well, I squared. I equals the square root of negative 1. Well, I want I squared. So I'm going to square the I, which means I need to square the right side of my equation. When I square a square root, that cancels. And I'm left with negative 1. So this is negative 4 times negative 1, which is positive 4. So now I'm going to finish combining my like terms. So I have x squared. Then I have negative 3x and negative 3x, which is negative 6x. Then I have 9 plus 4, which is 13. Now, don't get your hopes up because we are not done yet. I still have the x squared minus 8x plus 16. So now I need to go through and I need to multiply that, the x squared minus 8x plus 16 through. So just like I did in the last one, I'm going to look at those as three things that I need to distribute. So x squared times x squared minus 6x plus 13. Negative 8x times x squared minus 6x plus 13. And 16 times x squared minus 6x plus 13. I'm glad I remembered to bring my calculator home today. Okay, so now let's multiply. X to the fourth minus 6x cubed, because we're adding our exponents, plus 13x squared minus 8x cubed plus 48x squared minus... Okay, hold on. I gotta do 8 times 13. Okay, let's see here. 8 times 13 is 104. So minus 104x. Now I'm going to distribute the 16. 16 times 6, 96. Plus 16 times 13, 208. All right. Now we have a lot of terms that we do need to combine. So I'm going to start with my x to the fourth, because standard form is largest exponent to smallest exponent. So I have no other x to the fourths. Now I'm going to look at my x to the thirds. Negative 6, negative 8. Okay, that's easy. So negative 14, x to the third. Now I'm going to look at my squares. Okay, not going to be as easy. So 13 plus 48 plus 16. I really hope I don't have a mistake in here somewhere, because that would really suck. Plus 77x squared. Now I'm going to look at my x's. Negative 104 minus 96. And I get negative 200. And plus 208. Now it makes sense that these numbers are kind of big, because I had a 16 that I was multiplying. I had a 13 that I was multiplying by. So it is probably likely that this is correct. But if you guys do see a mistake, point it out to me tomorrow, and I can get that fixed. But I think it looks pretty good. It is a lot of work. You can't be lazy with these. You get lazy, mistakes happen. So just persevere through these. Don't give up on them, and do the best you can. And just know that you're not doing anything new here. You guys have been multiplying polynomials for several years now. And we're just applying our knowledge of the complex conjugates to help us write this polynomial. If you need to watch it again, watch it again. Make sure that you take your time with these. All right. I know this video is getting long. We only have one more example left. And I am going to show you how to do this with long division. I showed you how to do this with synthetic division in 4.5. You are welcome to use synthetic division here. It's just another option. It's very user friendly, but keep in mind that you do have a lot of guess and check that is involved with synthetic division. I am going to show you how to do this with long division, which does take away the guess and check, and it makes this very, very straightforward. So find the remaining zeros, and it doesn't say real zeros, it's all the zeros. By the time we are done with this, we need to have, for A, 3 solutions. So I'm going to look at this and I'm going to see, oh look, they're giving me a solution, 2i. So what's the conjugate pair? Negative 2i. So I know 2 solutions already, and I'm going to write those as factors. X minus 2i and x plus 2i. So I know that this equals x and this one equals x, and so I'd have to move them over to make them equal to 0. So I'm missing one solution. Again, you can go through, you can find your p's and your q's, and then you guys can use guess and check with synthetic. But I'm going to multiply this through. So I'm going to distribute the x, which gives me x squared plus 2xi. Then I'm going to distribute the negative 2i, which is negative 2xi, and minus 4i squared. Well, those cancel. And then in the last example, we talked how the I squared is negative 1. And when I multiply negative 4 times negative 1, I get positive 4. I can now take this factor. This is a factor. I can't use synthetic with it because it's a quadratic factor. It is not a linear factor. I'm going to use long division with this. Long division can be used with any polynomials. They don't have to be linear. So since the x squared minus 4 is one of my factors, I'm going to divide by x squared minus 4. So I have x cubed minus 4x squared plus 4x minus 16. With the long division, you will have to completely finish long division, not like when we were doing oblique asymptotes. So I'm going to go all the way until I have finished this. Now the factor theorem says, if I divide by a factor, my remainder will be 0. Since x squared plus 4 is a factor, when I'm done with this long division, I should be left with 0 as my remainder. So long division, we've been using long division, so I'm not going to go over this too slowly. If you need it again, just watch it again. I start with my first term, x squared, and I have to figure out what do I have to multiply by to get x cubed. Well, that's x. So then I multiply. I get x cubed. Now, I get plus 4x. Well, this is an x squared, so I'm going to come over here and put plus 4x. Because this becomes subtraction, I change my signs. X cubed cancels. I have to bring down the negative 4x squared. And 4x minus 4x. Ooh, nice. That one canceled too. And then bring down the negative 16. Now I have to ask myself, x squared times what is negative 4x squared? Well, I'm missing the negative 4. Distribute to your factor again. And you get negative 4x squared minus 16. This becomes subtraction. Because I'm subtracting these, they both become addition. And look at that. They cancel. I'm left with 0. So the x minus 4 is my other factor. So I'm going to take the x minus 4 and I'm going to set that equal to 0. So x equals 4. So my zeros are x equaled 2i and negative 2i, and then I also found 4. My degree was 3. I was looking for 3 solutions, and I found them. All right, B, last one. We're almost done, you guys. Hang in there. Now this one, this is a whopper of a problem, but it is very doable. I would stay away from synthetic because my ending term is 60. There are 12 numbers that divide into 60. And then you have the plus or minus. So then you're looking at 24 possibilities. I don't want to take that chance. So I'm given 1 0. And so I know my other 0 is 1 minus 3i. So I'm going to write those as factors. So just like I did in the last one, x equals 1 plus 3i. Well, that becomes x minus 1 minus 3i equals 0. And then x equals 1 minus 3i is the other factor. So x minus 1 plus 3i equals 0. So I have x minus 1 minus 3i, x minus 1 plus 3i. Okay, now I'm going to multiply this through. Now I'm not going to write it out like I did in the last example. I'm going to do some mental math here. When I distribute the x, I get x squared minus x plus 3xi. Now I'm going to distribute the negative 1. I get negative x plus 1 minus 3i. Now I'm going to distribute negative 3i. And I'm distributing it to this parentheses, you guys, if you're kind of lost. So I distribute it. I get minus 3xi plus 3i minus 9i squared. So I'm looking here, my 3xi's cancel, my 3i's cancel, and this becomes positive 9 because I squared is negative 1. So I have x squared minus 2x plus 10. So that's my factor, my other factor. So x squared minus 2x plus 10 divides into x to the fourth minus 7x cubed plus 14x squared minus 38x minus 60. So let's get this party started. So x squared times what is x to the fourth? X squared. So I distribute it through. I get x to the fourth minus 2x cubed plus 10x squared. Because I'm subtracting, I need to go through and change all of my signs. X to the fourths cancel. Negative 7 plus 2 is negative 5x cubed. 14 minus 10 is 4x squared. Then I still have the negative 38x minus 60. So now let's divide again. X squared, to get negative 5x cubed, it needs a negative 5, and it needs an x. Now I multiply again, and I get negative 5x cubed plus 10x squared minus 50x. Now I need to subtract, which means my signs change. So plus, minus, plus. 5x cubes cancel. 4 minus 10 is negative 6x squared. Negative 38 plus 50 is 12x. And then I still have the minus 60. All right, nothing else to drop down, which means this is going to be the last one. And don't forget, your remainder should be 0. But make sure that use that as a tool to know if you are dividing correctly. We're going to be factoring soon, though. So I have x squared. What do I need to get negative 6x squared? I need a negative 6. So now I want to verify. I could stop, but I want to verify that I am doing this correctly. So I get negative 6x squared plus 12x minus 60. And then I need to change my signs. Plus, minus, plus. Oh, thank goodness. They all cancel, and I do get 0. So that was a factor. My multiplication was correct. My division was correct. So now I'm going to take the factor that I found. So I found x squared minus 5x. So let me do this work down here. X squared minus 5x minus 6 equals 0. So I need to solve this one for x. So I have 2 solutions found with my complex conjugates from the beginning. But there are 2 more. My degree was 4. I'm looking for 2 more solutions. So I need to recognize that I can factor this. What multiplies to 6, that adds to negative 5. So I have negative 6 times positive 1. That will give me negative 6. And when I add those, it will give me negative 5. So x minus 6 and x plus 1 equals 0. Zero product property, so x equals positive 6 and negative 1. And then my other two solutions from the beginning, 1 plus 3i and 1 minus 3i. So there's all of my solutions, all four of them, real and imaginary. Again, you are welcome to use the synthetic division if you guys want to go through and do the guess and check. I think you're insane to go through and do that. Good luck with that. Long division, you guys, is not that difficult. You guys can work through that. Just take your time. This is a homework that you guys do need to persevere through and just do the best you can. And come with questions tomorrow and I will gladly help you. Watch this again, pause it, add any notes that you need to the notes that you guys had already taken. And I'll see you tomorrow.